Hi, this is Mr. Minnick doing Tracing Arrays and Functions worksheet number 1. We have an array here named mnums, and we have to trace how it's used in this form load method. The first exercise is to figure out what prints in label 1. So let's first realize that there's a function called sum that's typed out down below this point on the worksheet. And here is the function sum. It returns an integer and it accepts a parameter that's passed to it. And the parameter in this case is this whole array. This whole array is passed as the parameter mnums, which plugs in for nums. So I'm not going to create a little array nums here. I could do that and store those same numbers inside of this array if I wanted to, but I don't have time or space on my paper to do that right now. So let's just kind of use the array as it's written up here as we trace this function sum to figure out what's returned. Okay, let's begin. First, when doing a problem like this that involves an array, it's important to label the subscript positions. So let's do that carefully so that you know what the index position numbers, also known as subscripts, are for these actual numbers that are in the array. Okay, we're executing this code right here. Dim sum as integer equals 0. Put a little 0 there. Then we hit this for loop. This for loop executes a bunch of times, and it begins with the loop variable j, starting at the number 0. Let's record that 0 there. And we need to calculate what this expression nums.length minus 1 simplifies to. Well, nums is the array that mnums gets passed to. So the length of nums is really the length of mnums. And so mnums is declared up here. Its length is 1, 2, 3, 4, 5, 6, 7, 8. Its length is 8, and 8 minus 1 simplifies to 7. So what we really have here on our hands is the number 7. In fact, we're going to go j equals 0 to 7. That minus 1 is important because that keeps us landing on the last element of the array, and we don't go one too far. Okay, so j is currently 0, and we execute this line of code. Since j is currently 0, nums 0 is the number 0. This 0 right here, coincidentally, is in position 0. And that 0 is added into the variable sum because of the plus equals. So that 0 gets has a 0 added to it. And then we hit the word next, which loops us back up to the top. J steps up to 1. And now we go through the loop again. But this time, J is 1. So that takes us up here to the array. And we're looking at the position, the number that's in position 1, which is a 2. So this is really simplifies to the number 2, which adds into the variable sum. And now we have a 2 there. And then we loop back up to the top. J bumps up to 2. We go through the loop. And now that j is equal to 2, we take our eyeballs up here and we look at index position 2 where there happens to be a 30. So all of this is really the number 30 this time. The 30 plugs into sum, adds into it. 30 plus 2 is 32. And you can see the pattern. There's nothing tricky here. There's no if statement. It's simply adding up all these numbers into one grand total. We have a 2 plus 30 is 32. Then we're going to add the 14, which is going to make 46 when j is 3. When j bumps up to 4, we're going to be adding in 15, so that will be 61. Then when j bumps up to 5, we're going to be grabbing this 26 and adding to the 61, which is 87. Then j is going to bump up to 6, and that's going to cause this 5 to be added into 87 from 92. And finally j is going to hit 7, which tells us that this 11 is going to be added into the 92 for 103, and the loop will go back to the top, and j will hit 8. But because j is 8 at that moment, and 7 is the upper limit, it will not go through the loop that last time, which is good because there is nothing in position 8. There's nothing there. That would cause the computer to crash if the programmer put an 8 there. So this -1 was very important. A lot of programmers use the dot length method, but they forget to put a -1 there, and you need that -1. Otherwise it won't work. It'll crash. So your answer here, even though I didn't have enough room in this area of the worksheet, circled under sum, I guess I should have put this 46 up here, and the 61, and the 87, and the 92, and the 103 could have been squeezed up here. Sorry about that. And same for the j. I like students showing all of the scratch work. Even if you see a pattern, I want you to show on worksheets like this your scratch work. Okay, and that's a little sloppy there, so that's the number 103. Let's circle that nice and carefully. And printing out then, no, I'm sorry. We now that we're finished with the for loop, we execute this line of code that says return sum, which is the number 103. And that 103 gets returned back up to where we called this function. So all of this really simplifies to simply the number 103, and that number 103 from right to left plugs into label 1's text property, which we're pretending is right here, 103. Okay, so in the end here, exercise 1, after it's all said and done, we have a reusable function, sum, that adds up all the numbers in this array. And that's a handy thing to have. So because this is typed out as a private function, end function there, this code could be copied and pasted and put into other projects where a programmer has a bunch of numbers in an array, like grades, student grades in a teacher's grade book, game scores in a game, like your score from different rounds, all kinds of things in the real world would need arrays, and they would need a function that, like sum, that adds this all up. Okay, the rest of this worksheet. In number 2, which you can do on your own, let's just hit the highlights right here. In number 2, the array mnums, again, will be passed as a parameter, which plugs in for a parameter named nums. What a coincidence. And we have a variable sum, and we're using j in a for loop. J starts at 0, just like it did up here. And j also ends at nums length -1, which was the number 7. That's going to happen here as well. That's just the number 7. But notice we have step 2. So j is going to start at 0 but go by 2's, etc. And we're going to be adding stuff up just like we did here, and returning some just like we did here. But because we're going by 2's, we're only adding up these numbers from the array. What's in the 0 position, the 2 position, the 4 position, and the 6 position. For some reason, you might only want the even numbered elements in this array to be added up. So I can see that the total should be 0 plus 30 plus 15 plus 5, which ends up adding up to 50. So the answer will be 50. 50 gets returned and plugs in here some of the even positions. So that's going to be the answer. But to get full credit on this worksheet, I want to see your scratch work. I want to see the scratch work and circle the final values here for these two variables. Looking ahead at this find function, this is a great reusable function, find. It also uses a for loop. It also has the array being passed to it as a parameter, but it also has this additional parameter key. Let's take a look to see what that ends up being. 7. 7 gets passed and plugs in for a key, so you're going to be putting a 7 there. J is again a loop variable. It's going to start at 0. And look at this. We have an if statement inside of our for loop. We did not have that in the previous two exercises. This if statement is basically looking for the number 7. It's looking for the number 7, and when it finds it, it returns J. So let's just kind of do this manually without tracing the code, and you can trace the code for the rest of your homework. Let's start here on the left of the array, and is that the number 7? No. So we loop. Is that the number 7? No. So we loop. Is that the number 7? No. If that's the number 7, no. If that's the number 7, false. Hey, we're never going to find the number 7. If we never find the number 7 in this function here called find, we end up returning -1. But if we do find the 7, let's pretend that one of these numbers was 7, like this one right here. When we do find 7, the position number, the subscript, gets returned, the J, 3. So 3 will be returned and end up being the answer. But if we don't find the 7, it ends up returning a -1. Why -1? Well, because there is no negative subscript. That's not allowed. So we use -1 to show that, well, we didn't find it. In the next exercise, this reusable function finds the maximum number in the array. Well, let's do that with our eyeballs. Let's do that right here with this array. Is 0 the max? Well, you don't know yet, so let's just keep track of 0 and proceed. Is 2 bigger than 0? Yes. So overwrite that. Is 30 bigger than 2? Yes. Is 14 bigger than 30? No. Is 15 bigger? No. Is 26 bigger? No. 5? No. 11? No. So our max is 30 if you scan this with your eyeballs from left to right. Well, that's what this code is doing. It's examining this array, going from j equals 0 again to j equals 7. Oh, I'm sorry, I'm looking at the wrong code segment. This function right here. J starts at 0, it goes over here, and it uses an if statement and this variable max to figure out that 30 is the number that gets returned as max. I want to see your scratch work. And finally, this function, position of max. Instead of returning the max number, it returns the position where the 30 was found. Well, the 30 is found in position 2. You can see that here by looking at my scratch work. Position 2, that's where the maximum number is. Sometimes you don't really care what the biggest number is. You care where it is in a lineup or where it is in an array. So that function finds the position of max and not max itself. And this function, sum of the even values. All numbers that are even, when they mod by 2, it equals 0. And I'm using bad style with a one-line if statement, but I wanted to keep this worksheet as a one-page worksheet, so I kind of violated my own coding standards by using a one-line if statement. If this is true, then this executes. If this is false, this part after the word then does not execute. Good luck with that function. Remember to show your scratch work for full credit.